Welcome back to yet another example of a determining transformation. So here we're being asked to find a sequence of transformation that takes this to this. Now let's just see how we go here. I might just do by inspection, because we've already done so many examples, and I think for this one just doing it by inspection will suffice for our understanding. So remember, the very first thing you need to do when you do it by inspection is to make sure you factorize. But as you can see here, I don't have to. So it makes it much easier. That means I can just simply read off what's happening here. So remember, first read off your transformations. Sorry, the first transformation you read is your dilation. So I've got this 2/3 here. So what that means is that I have a dilation of 2/3. So make sure you have the right language here. A dilation by a factor of 2/3, and it's going to be from the x-axis, from the x-axis. Now I don't have a dilation from the y-axis, so that means I go on to my next transformation, which is a reflection. And as you can see, I have a reflection out the front of this whole thing. So that means I have then, make sure you use the word then a reflection in the x-axis. And then I'm going to read off my transformations, the next transformation, which is translations. So I have a 3 here and then a -1 there. So that means what I'm going to end up with is then a translation of 3 units in the negative x direction and 1 unit in the negative y direction. And we are done. So just to reflect on what we've done here, I first began with a dilation by a factor of 2/3 from the x-axis, which I read from there. Then I read off my reflection, so that's -3, then a reflection in the x-axis. Then I read off my translation, so a translation of 3 units in the negative x direction, which I read from there, and 1 unit in the negative y direction, which I read from there. Now, let's do by the method. Let's just do it, just for completeness sake. So now I'm going to do by the method, and I will get the same answer. So to do this by the method, I start with x, y, and I'm going to x dash, y dash. My original graph is y is equal to 1 on x, and the graph that I'm going to, let's not mess this up. Oh, that's a beast. Y equals -2 on 3. Then it was 1 over x plus 3 minus 1, like that. Okay, now that I've got that, the next thing that I do is I put my dashes in. Then I rewrite my left-hand side the same. And I'm now going to rearrange this. I'm going to get y plus 3. Sorry, plus 1, because I'm going to plus 1 to get rid of this -1 there. And now I need to get rid of this. Now, let's just do this in one step. What this is going to end up being is there's going to be a 3 here, a 2 here, but it's going to be, what's the best way to do this? Y plus 1, let's put this all in brackets, and then put -3 on 2 at the front, like that. And this is going to be equal to 1 on x dash plus 3. So as you can see, I took everything I could over to the left-hand side, and now I'm just left with that. Now the next step is equating. So this y is going to be equated with this. Oh, my dashes. Make sure you got those dashes. And then I'm going to have x being equal to that. So I'm going to get y is equal to negative 3 on 2, y dash plus 1, and x is equal to x dash plus 3. Okay, so that means I'm going to end up with, over here, negative 2 on 3y is equal to y dash plus 1. Then it's going to be negative 2 on 3y minus 1 is equal to y dash. So that means y dash is equal to negative 2/3 y minus 1. And then on this side, it's super duper easy. It's just x dash is going to be equal to, and let me just do this slowly so we don't make any silly mistakes here. So we got that. So it's going to be x dash is equal to x minus 3. Okay, so that is one side, and that is the other side. Okay, now we can say the following. We can say that I started with x, y, and I then got x dash, y dash. So I started with x, y, and I know that x dash is equal to this, x minus 3, and I know that y dash is equal to this monstrosity. Look at it, like that. Once I've got this, I can now start reading off my transformations. So I begin first with my dilations. So as you can see, I have 2/3 here. So this is going to be a dilation of make sure you get the language right, a dilation by a factor. I'm like telling myself off. Dilation by a factor of 2/3 from the x-axis. Then the next thing that I'm going to read off is my reflection, which is here, this negative. There's going to be then a reflection in the x-axis. Then I have to read off my translations, which are here, which is going to be, is that what I got up here? Both negative. Yeah, cool. Then a translation of 3 units in the negative. This must be so boring to watch. Negative 3, sorry, translation of 3 units in the negative x direction, and 1 unit in the negative y direction. If I could make it more exciting, I would, but unfortunately transformations aren't that exciting. So if I was to read this, dilation by a factor of 2/3 from the x-axis is read there. Then I read off my reflection. A reflection in the x-axis is seen there. And then finally, I've got a translation of 3 units in the negative x direction, which can be seen there, and 1 unit in the negative y direction, which can be seen there. And that answer is the same as we got all the way up here. A dilation of 2/3 from the x-axis, a reflection in the x-axis, a translation of 3 units in the negative x direction, and 1 unit in the negative y direction. Perfect. Hopefully you found that helpful and you're able to get those answers. I will see you in the next part of this video. Yep, there's more parts. Thrilling, I know.